Hello everyone, welcome to our new lecture of Automata and Computability Theory. In this lecture, we are going to design a DFA for the language or for the set of all strings that are at least of length 4 and contain an even number of 1. Now, you might think it as difficult based on the previous regular expression example for this language, but believe me, the DFA is quite easier than the regular expression example. So, now this question have two conditions. One, the strings will have at least length 4. So, that means the strings can have length greater than or equal to 4 and will have even number of ones. So, at first we will make a DFA for length equal to 4 and then we will handle the greater part. But at first let's focus on the length equal to 4, right? And as it said even number of 1, so that means there are two parts. The strings can have odd number of 1 and also have even number of 1, right? So let's divide two part for our DFA. So this upper part will have even number of 1 and this lower part will have odd number of 1. So as there are the length is 4, so there will be 5 steps for the even part. Length 0, this is length 0, then length 1, so this is length 1, length 2, this is length 2, length 3, this is length 3, and length 4. Now for the odd part there won't be any length 0 because to go to the odd part we must have at least one symbol, right? So length 0 cannot be possible for the odd part. So in the odd part there will be length 0, length 1, length 2, length 1, length 2, length 3 and length 4, right? So this is length 1, this is length 2, this is length 3, this is length 4. Now if we see that then the condition is on the number of 1, but for the zeros there is no condition. That means there can be any number of 0, odd or even, it doesn't matter. But if we look at it, then the number of zeros will increase our length, right? So a0 10 doesn't contribute on the length on the number of 1. So it doesn't matter if the number of 1 is even or odd, the 0 doesn't contribute on that. But what 0 does is that it increases our length because it is on symbol, right? So getting 10 means our string, the length of our string has been increased by 1. So if we are at the length 0 and we get a 0, so our length will be 1, and similarly from length 1 to length 2 for 0 the length will become 2, and then 2 to 3 and 3 to 4, right? Similarly from 1 to 2, 2 to 3 and 3 to 4. As I have said that 0 doesn't contribute anything on the number of 1, but it increases our length, so we are increasing the length. Now from length 4 we will, as this is the even part and this is the odd part, so we will use this length 4 as both length 4 and greater than 4. So as I said that 0 increases the length, so 0 and 0. So this is now greater than or equal to 4. This is now greater than or equal to 4. So we are done with 0, but we can have 1 too. Now how will our DFA act? when we get a symbol of 1. Now if we are in an even state, that means we have even number of 1, right? If we are at this even state, we will have even number of 1, and then if we get another 1, then we even plus 1 equal to odd. That means if we are in even state and we get a 1, we will move into the odd state, right? We will move into the odd state, and also our length will be increased by 1 because 1 is a symbol. So a new symbol means our length will increase by 1, and if we are at even state, then we will go to the odd state. So if from this length 0, if we get a 1, that means our length is increased by 1. That means we will go to the length 1, and as a 1 came, so from even state we will move to the odd state. So similarly from length 1 to length 2 and even state to odd state, length 2 to length 3 and from even state to odd state, length 3 to length 4, even state to odd state. And as the 4 is acting for both greater than and equal to 4, so we will move back to here. Now similarly, odd number of odd number of 1 plus a new 1 will make it even number of 1, right? Even number of 1, and the length will increase by 1 too. So that means from odd state and from length 1 we will go to length 2 of even state, and from 2 to 3 of even state, 3 to 4 of even state, and from here to here of even state. Now which one will be our final state? As it have to be both at least of length 4 and even number of 1, that means this will be our final state, as this is maintaining both the length and even number of 1. So this is our solution. And our steady state will be this. So that's it. Thank you.